Hello. Hello. Hello.
Good morning, sir.
Good morning. Good morning, all. I think some people are joining.
Morning, sir.
Morning.
Morning,
Okay.
sir.
Morning. Okay. So today, first we want to discuss that one problem that I am supposed to discuss. That circular convolution of two sequence, say 2, 1, 2 minus 1. Another sequence is 1, 2, 3, 4 using tabular method. Right. So previously there was some confusion regarding the value. Now, if you start with this problem, first you have to find the circular convolution of x1 and x2, and that will be your x3 of n. Now, we'll write 0, 1, 2, 3, and we'll write minus 1, minus 2, minus 3. That is the value of m. Now, x1 of m, I am taking 2, 1, 2, minus 1. So 2, 1, 2, minus 1, that is x1 of m. Now, x2 of m, that is 1, 2, 3, 4. So all digits are different. Now, 1, 2, 3, 4, first I have written x2 of m. Then x2 of minus m, I will start from minus 3. So if I start from 0, so let us write 1, 2, 3, 4, like this. Okay, so x1 of
Reverse
m,
order.
so x2 of m, I will start from 0 and write 1, 2, 3, 4. Then I will write 4, 3, 2. So 4 will be here, 3 will be here, and 2 will be here. Okay, so we'll write like this. Now x2 of 1 minus m, I'll start from 1. I have put a tick here. So 1, 2, 3, 4. Then I'll fill up like 4 and 3. Okay. Then x2 of 2 minus m, I'll start from 2 and I'll write 1, 2, 3, 4. Then I will write 4 over here. Next, I will see that x2 of 3 minus m. So I'll start from 3. So 1, 2, 3, 4. Like that. So once we fill up the table, have you understood this table? So once
Yes,
you
sir.
understood the table, that is not
Yes.
good. So problem what I am saying that how do I note x2 of minus m, I will start from 0. x2 of 1 minus m, I will start from 1 and write in this order 1, 2, 3, 4. 2 minus m, I will start from 2, write 1, 2, 3, 4. 3 minus m, I will start from 3, 1, 2, 3, 4, like this. Then while writing, filling up these blocks, first I will fill 4 here, then 3 here, then 2 here, then 4 here, then 3 here. Now you have to multiply x1 of n with x2 of minus n. Then Then I will multiply 2 multiplied by 1, 1 multiplied by 4, 2 multiplied by 3 minus 1 multiplied by 2. That gives you 10. Then next, x1 of m will be multiplied by x2 of 1 minus m. So 2 will be multiplied by 2, 1 will be multiplied by 1, 2 will be multiplied by 4, minus 1 will be multiplied by 3, like that. And x3 of 2, x3 of 2 means 2 minus m. 2 minus m means this is like this. So I will multiply 2 multiplied by 3, 1 multiplied by 2, 2 multiplied by 1, and minus 1 multiplied by 4. This is the 6. Next, x2 of 3 minus m. So this will be 2 will be multiplied by 4. So 2 into 4, 1 into 3, 2 into 2, minus 1 into minus 1. Like that. 2 into 4 into 2, 2 into 1, 2 into 2, 1 into minus 1. This will be nothing but 14. So with this, we have calculated 10, 10, 6, 14. So this is an example which we are supposed to give that I have given. All right. Now, if this is okay, then we want to start another topic that is called section convolution. Section convolution, this is one of the topic mentioned in the syllabus. In this, we are having two methods for section convolution. One is overlap add method, another one is overlap save method. Now, section convolution means, suppose if one data is very large and another data is small, right? So section convolution, are you hearing properly?
Yes, sir.
Okay.
Yes, sir.
So section convolution, this is one topic that is mentioned under DFT that I want to discuss. What is section convolution and why that is required? Suppose one data stream is very large, another data is small. In such a case, suppose data is available in real time. So data is coming one after another. And you have to find the convolution of the impulse response of the system to get the output. And there are two types of convolution which I have discussed so far. One is linear convolution, another one is circular convolution. In section convolution, there are two types, I said, overlap add method and overlap save method. In overlap add method, we use linear convolution, and overlap save method, we will use circular convolution. Again, indirectly that is performing linear convolution only, but the technique that is mentioned in the literature that we use circular convolution in overlap save method. This topic comes under the DFT section under the term of long data filtering. Filtering long data. Filtering long data, in that two methods are mentioned in the syllabus. Now, filtering long data means what? If a signal is coming, large data sequence, but impulse response of a system is smaller. Then you have to find the convolution and compute the output in real time. Now the question is, when data stream is coming, if you wait for the entire data stream to available, therefore there will be a processing delay. But until the data is available, you cannot, entire data if you wait for, the entire data availability may require certain time. Therefore, instead of doing that, whatever data available, you compute the convolution, then next set of data is coming, then again you perform the convolution. What is known to you, that is impulse response of the system. Right? Therefore, for such kind of data, when you are having long, big data, then you have to divide the long data, having more number of samples, into smaller sections. right? So when you are having a large number of data set available, then dividing into a smaller section and perform convolution with your impulse response, then this is known as section convolution. This is required to save the time or delay, because if we wait for the entire data to be available, then there will be a delay. Therefore, whatever data available, first to perform convolution, next set of data available of the long data, again you perform convolution. Like that, this is the procedure. Then this is called a section convolution. Now, section convolution, when I said there is two methods, one is overlap add method, another one is overlap save method. Now, first we will discuss overlap add method. Before that, I want to revise linear convolution a little bit, because we have studied this little earlier. Now, suppose x1 of n, right? x1 of n, what is the data? 1, 2, 3. And it is n equal to 0, n equal to 2, right? N equal to 0, 1, 2, 3 data. x2 of n, 1, 1, 1. So this is, suppose say n equal to 0 points. Now again, n values 0 to 2. All right. Now, if we find the convolution of this, Acha, what is the length of this? Length of this x1 of n? 3. So length of x1 L1 equal to 3. So length means what I understand, number of data points in x1 of n. Since the number of data points in x1 of n is 3, so length of this is 3. Now suppose x2 of n, what is the number of data point? 3, because 1, 1, 1. So length of this is also 3. Now this data 0 to 2, this data 0 to 2. So what will be the output of the convolution range? It will be 0 plus 0 and 2 plus 2. This will be 4.
0 to 4.
All right. So what I know, the output of the linear convolution, that will vary from 0 to 4. That is the sum of the lower limit of x1 of n and x2 of n, and sum of the upper limits of x1 of n, x2 of n. That will be the length of the output of the linear convolution. Then x3 of n equal to x1 convolution, x2 of n, this will be, I will write 1, 2, 3 and 1, 1, 1. Then you multiply 1 into 1, 1, 2, 3, and again 1 into 2, 1 into 3, 1 into 1, 1 into 2, 1 into 3. So the first value is 1, then 3, then 6, then 5, then 3. This will be the output. Now, of course, we will see the output will be n equal to 0 up to n equal to 4. So 0, 1, 2, 3, 4. So what is the length of this? The length of this will be, length of this how much?
5.
Length of x3 is 5.
5.
So what I can write, that length of x3 of n, that will be L1 plus L2, L1 plus L2. Hello? আচ্ছা, আমি একটু ক্লাসে আছি, আমার 10:30টায় ক্লাস শেষ হবে, 11:30টায় ক্লাসে পরে ফোন করবো, ক্লাসটা শেষ হয়ে যাক। হ্যাঁ, ঠিক আছে। হ্যালো, ওকে। So what is x3 of n? x3 of n is 1, 3, 6, 5, 3. So length of x3, that will be L1 plus L2 minus 1. L1 is how much? L1 is 3, L2 is 3. So 3 plus 3 is 6. 3 plus 3 is 6 minus 1. That will be 5. That is the length of x3. Tale, what is the conclusion so far? In a convolution or linear convolution, what I conclude, that if the number of data points in x1 of n, that length or length of x1 is L1, length of x2 is L2, then once we convolve x1 and x2, the corresponding signal I will get x3, that will be equal to length of that will be L1 plus L2 minus 1. And the limit of x3 will be sum of the lower limits of x1 and x2 and sum of the upper limits of x1 and x2. Agreed?
Yes, sir.
Right. So this is very important. That is important thing, and you have to note this, that in a linear convolution, length of the output will be the sum of the length of the outputs of the two signal which is convolving minus 1. Length will be two signals total length minus 1. That is the length of the output. And the output limit will be sum of the lower limit of the inputs and other signal and sum of the upper limit of the x1 and x2. This is the two things I would like to conclude from this entire example. Now, method. See, in overlap add method, the longer sequence is divided into smaller sequence, which I have explained. The signal which is longer, that I have to divide it into smaller sequence. Okay. Now, the linear convolution of each section of the longer sequence and smaller sequence is performed. What does it mean? Suppose if you are having longer sequence, then I have sectioned this into smaller sequences. Then each smaller sequence we have to convolve with the other sequence. Suppose x1 of n having 8 points, right? So now we have divided this 4 number of 2 points, and suppose your x2 having 2 points, right? Therefore, the point what is written here in overlap path method, longer sequence is divided into smaller sequences. So longer sequence is x1 having 8 points, then I divided into 8. Now let us take this example, then it will be very clear. Then we will explain the theory with the example. Suppose x of n having 8 points, right? 1 2 3 4
স্যার
5.
অডিওটা প্রবলেম করছে আসছে
Just আসছে না, এবার আসছে?
আসছে ক্লিয়ার।
আসছে তো?
ক্লিয়ার আসছে।
আচ্ছা ঠিক আছে।
আচ্ছা ক্লিয়ারই আসছে।
আচ্ছা ওকে। So x of n, if you are having suppose say 8 points. Now if I divide this into a smaller sequence means suppose this hn is how many? 2 points. Now I am dividing this into 2 points, but not necessarily they have to be same. They may be different, but they may be same also. Now if I write dividing this is to x1 x2 x3 x4, 4 different signal. I am dividing into 4 sections, and this is your smaller sequence. This is your impulse response. This signal is a real time. Now suppose this smaller section, this is n equal to 0, next one is n equal to 1, this is n equal to 2, this is n equal to 3, n equal to 2, n equal to 3. Now this is 3 for n equal to 4, minus 3 n equal to 5, and this is 4 minus 4, I am writing 4 minus 4, n equal to 6, n equal to 7. What I am saying that first to have divided the larger sequence or longer sequence into smaller sections. Now I have to perform convolution with h of n. Agreed? Now I am saying what it is written in the theory. It is written in the theory that what we have written. I hope this part is the overlap as matter, longer sequence divided into smaller section, then linear convolution of each section of longer sequence and smaller sequence is performed. I hope this line is clear. Okay, is it all right? This up to this
লঙ্গার
Yes, sir.
huh?
স্যার আরেকবার বলুন
The longer sequence that you have to divide into smaller section, and one sequence is smaller, so that is not an issue. So the which sequence which is longer sequence, that I have to divide into a smaller section. Okay, right? Now the overall output of the sequence is obtained by combining the output of each section convolution. মানে কি? প্রত্যেকটা সেকশন, তাহলে প্রত্যেকটা যে সেকশন, this is one section, this is one section, this is one section, this is one section corresponding to this longer section. Now I have to we have to convolute hn with this section x1 of n, x2 of n, x3 of n, and x4 n. Then we will get 4 results corresponding y1 of n, y2 of n, y3 of n, y4 of n. That is obtained x1 n convolution with hn, I have got y1 of n. x2 of n convolution with hn, I have got y2 of n. And x3 of convolution, x3 of n will be convolution with h of n, I have got y3 of n. And x4 of n, if I convolve with hn, I will get y4 n. Agreed? So I have got 4 output, and here it is written that the overall output sequence is obtained by combining the output of each section convolution. Each section convolution, প্রত্যেকটা সেকশনের whatever be the convolution result, that I have to combine, and that combination will be the output. That's why this is called overlap add method. That means we have to combine those output, and overlap I will discuss later. First, this 4 section convolution that I have to combine to get the final output, that is y1, y2, y3, and y4. If I combine these 4, I will get the final output. Okay, so this section convolution, why this section convolution, that I have already discussed, because once the data may not be available all together, one by one, maybe this set available, next this set available, next will be this set available, next will be this set, maybe many set beyond that also. I have, for example, I am taking 8 data set. Okay, now tell me one thing, y1 will be the convolution of x1 of n into h of n. So what is the limit of the output? Limit of the output will be 0 plus 0, and this is 1, this
0
is
to
1, 0 to 2. Sum of, I'm talking about x1 and h and the convolution. Sum of the lower limit is 0 plus 0. Sum of the upper limit 1 plus 1, 2, 0 to 2. Okay, limit of the output, everybody agrees with that? Everybody agrees with that? Very good.
Yes, sir.
Now tell me limit of y2. Limit of y2 क्या है बोलो देखिए, देखिए बोलो. 2 plus 0, 2,
4 to 6.
2 to 4,
2 4
2 4.
2
0 plus 2 আর 1 plus 3
হ্যাঁ, এইটা কথা হবে। তারপরেরটা, তারপরেরটা
ওটা
4 to 6.
4 to 6, তারপরেরটা
6 8.
6 8. বুঝতে পারলে? Now what you observe, that this is 0 to 2, but here again 2 to 4, so 2 is common in this. This is 0 to 4, again 4 is common, again 6 is common. All right, fine. This is what we have seen. Now if we look at this, now what is saying, now let us look at the theory again. N1 is the length of the longer sequence, N2 is the length of the smaller sequence. Okay, তাহলে N1 টা কত বলো তো? N1 টা কত? 8 আর N2 টা কত? 2 smaller sequence টা কোনটা? H টা হচ্ছে smaller sequence. Very good. Now let the longer sequence divided into size of n3 samples. N3 may be equal to N2. Now suppose that N3, the total J sequence, that is your N1, length of the sequence. Now that is divided into N3. Now the longer sequence can be the N3 sample. Now longer sequence can be divided into size of sample. Now if I see the convolution of the 2 sequence, right? Now 2 sequence, what will be the output length? Suppose smaller sequence that I have divided section, each section is having length N3. Each section having length N3.
Yes.
Fine. আর smaller section that is n2. I am having two sequence. What is x1? Length is n1. N1 is the length of the larger sequence. N2 is the length of the smaller sequence. Now n1 is divided into sequence, smaller sequence, which is length n3. Tell me what is the length of the output?
N3.
Length of the output? Total length of the output কত
Total
হলো?
out
হ্যাঁ
তো 9 হবে 8 plus 2 minus
no. I am talking about n1 is the longer
smaller sequence গুলো
smaller sequence এর length হচ্ছে n3. Smaller sequence এর length n3.
3 হবে 3 হবে
না আমি তা বলছি না।
হ্যাঁ
আমি বলছি n1 is a length of the longer sequence. I have divided into smaller sequence that smaller sequence length is n3. Okay, and n2 is the length of another sequence যেটার সঙ্গে কনভলিউশন করব। তাহলে টোটাল লেন্থ অফ দা আউটপুটটা কত হবে?
n3 plus n2 minus 1.
n3 plus n2 minus 1. Ki is correct.
n2 plus.
Ki is correct. Are you everybody following this? Everybody following this? Okay. Now
Yes.
n3 plus n2 minus 1. Right? Now, if you look at this example, now for this example, what is the value of n3? That I have taken n3 equal to
2.
n3 equal to 2, correct, and n3 equal to 2 and n2 minus 1 কত হবে? 1
হবে
তাহলে
1
হলো তাহলে
3
তাহলে
হচ্ছে
তুমি দেখ তাহলে n3 হচ্ছে কি কত 2 আর এটা হচ্ছে কি n2 minus হচ্ছে 1 তার মানে তুমি দেখতে what I am saying তাহলে একটা করে ওভারল্যাপ করছে one sequence is overlapping because 2 is 2 overlapping একটা overlapping তার মানে কি n2 minus 1 length will overlap with the next one হ্যাঁ একটা ওভারল্যাপ
করে করছে হ্যাঁ
আবার তারপরেরটার সঙ্গে তারপরের একটা ওভারল্যাপ করছে তাহলে there will be overlap right now then while computing the total output I have to add this way as it is at the overlap I have to add that's why it is overlap add method at the overlap we will add this will compute the total output right this is written in this theory now we go to the example you will understand this better now what I have to do I have to find the output of each section now what is the y1 n y1 of n that I have to convolve this 1 minus 1 with minus 1 1 minus 1 1 ta konta this one is this now if we convolve then if we multiply তাহলে y1 of n I can compute minus 1 into 1 minus 1 plus 1 1 into 1 1 into minus 1 তাহলে পয়েন্ট গুলো কি হবে minus 1 2
minus 1 2 minus 1
তাহলে again we will similarly convolute y2 with h of n then this will be minus 2 2 minus 2 হবে 2 minus 4 আচ্ছা এইটা কি হবে এইটা y থিটা এরকম হবে 3 minus 6 3 y4 will be 4 minus 4 8 minus 4 হবে because I have to convolve 3 4 minus 4 with minus 1 1 then we convolve then we will get these values now tell me this is starting from what is the starting point 0 to 2 0 to 2 and this is 2 to
0 and 2
and this is 2 to
2 to 4
4 2 3 4
this is 4 to 6
4 to 6
okay this is 6 to 8 very good now right
yes
8
I have written yn n I have written then I have written y1 of n y1 of n 0 to 2 what next y2 is 2 to 4
2 to 4
and
To
then
4.
y3 is 4 to 6
4 to 6
and then it will be 6 to 8
6 to 8
okay now I am combining let us combine 1 rest I will assume 0 2 then if we combine here minus 2 minus 1 minus 3 this is 4 this is minus 5 this is
minus 5
minus 7
minus 7.
8 minus 4. Okay. So this will be the total output using this method. Since wherever there is overlap, if we add this, that's why this is called overlap add method. So this computation technique, what is the advantage? Suppose entire data is not available initially. Then what happened? Whatever section is available, I'll find the computation, compute the convolution and store the result. Next section is available, compute the convolution, store the result. As the data will be available one by one, I will keep on computing the calculation. Now, if we wait for the entire data to availability, if we wait for the availability of entire data, then there will be wastage of time. Whatever small section available, compute the output and store. This will manage the save the time. Not only it will save the time, it also save the memory space. Memory space means entire data you have to store. Now you need not store entire data. You need not store entire data. You will store per section of the data, then compute the output and store it here. So large memory space you need not require. Once computation is over, you can erase the data, not required your data, because we have finally got the output. Therefore, this will not only save the time, it will also save the memory space. This is a real-time approach. Now, suppose if we want to compare, instead of doing this method, if we directly compute, this is, I'm just showing this example, this will give you the same answer. Now, suppose this is the data, 1, minus 1, 2, minus 2, 3, minus 3, 4, minus 3. This is the data. If I directly compute the convolution, then what happened? Minus 1 into this, if you multiply, this will be minus 1, 1, minus 2, 2, minus 3, 3, 4. Next, if you multiply by 1, this will be the result. Then you compute what is the data? Minus 1, 1 plus 1, 2, minus 1, minus 2, minus 3, minus 1, minus 3, 4. This is the time instant. This time I'm saying 0, 1, 2, 3, 4, 5, 6, 7, 8. This is what? 0, 1, 2, 3, 5, 8. So at 8, what is the data? Minus 4. At 8, what is the data? Minus 4. 4 plus 4 is 8. That is the data at 7. Data at 7, what is the data? That is 8. So every same method. So if we directly compute the convolution, once the entire data is available, then using this linear convolution, you will get the same answer. Or then if we calculate using the overlap add method, then you have saved the time, you have also saved the memory. You have saved the memory. This is the two advantage in using overlap add method. Right. Now the question is, now if we look at the theory, then I think I have explained the entire theory over here. Now the question here is, there are two types of question. Why I have written such theory? I have written such theory because there are two types of question. One is, suppose the longer sequence is given, you are supposed to ask compute convolution using overlap add method. That could be a question. Now, there are several times this has come as a short note. Write short note on overlap add method. If I have to write short note, then you have to write starting with this, you need not show. You write overlap add method. Then from this to this, you have to write. Up to this, you have to write. And if possible, you give this example. Right, but in short note, only giving example is not the solution. Then you have to explain the theory as well. Explaining the theory, if I summarize what it is there, it is there that if you are having a longer sequence of length n1 and you are having another smaller sequence that is length n2, and you have to find the convolution of longer sequence length n1 and smaller sequence length n2. What you have to do for such overlap add method, longer sequence n1 you have to divide into smaller section of n3. Now each smaller section of length 3 you have to find the convolution of another just smaller signal, that is n2 length, then you have to find the convolution. Length of the output will be n3 plus n2 minus 1, and n2 minus 1 section of each output will overlap with the next section, and this process continues until the sequence is over. So now wherever there is a overlap, you have to add those portions and you have to compute the total output. While adding the individual section output, you should assume the section which is not having any point as 0. Only where is the overlap that you have to add to compute the total output. And this method is for saving the time, at the same time saving the memory space. If you have any question, you can ask. Otherwise, I have only 4 minutes left.
স্যার এখানে n3 n1 1 এটা কি জন্য করেছেন এই যে সেকেন্ড লাইন
এখানে দেখো এটা প্রথম n2 1 টা তো ওভারল্যাপ হয়ে গেল।
হ্যাঁ হ্যাঁ ওটা বুঝতে পারলাম।
তাহলে এইখানে যে সেকশনটা ছিল তার মধ্যে কি ছিল? এটার মধ্যে শুধু n3 ছিল তো।
হ্যাঁ
এই সেকশন এরও তো লাস্টের n2 টা আগের সঙ্গে ওভারল্যাপ হবে। তাহলে এই টোটাল লেন্থ ছিল n3, তার থেকে n2 1 টা ওভারল্যাপ হয়ে গেল। তাহলে কি দাঁড়ালো এটা? n3 n2 1।
আচ্ছা n3 2
আচ্ছা এই দেখো ধরো এই প্রবলেমটা কত ভ্যালু হচ্ছে দেখো, এটার ভ্যালু 1, n3 তো 2 তো, তাহলে এটা হচ্ছে 1, এটা হচ্ছে 1, তাহলে এর একটা সিকোয়েন্স মাত্র এই জায়গাটায় থাকছে। টেক দিস এক্সাম্পল, লুক এট দিস এক্সাম্পল। এখানে দেখো না ব্যাপারটা ক্লিয়ার হয়ে যাবে। এখানে দেখো যেমন দুইটা এর দেখো 3 লেন, তো এইটা এখানে ওভারল্যাপ করছে, এইটা এখানে ওভারল্যাপ করছে, এর মাত্র একটা সিকোয়েন্স থাকছে ওই জায়গাটায়। তাহলে এই যে লেন্থটা ছিল n3 থেকে n2 1 বাদ গেল, তাহলে এই জায়গাটা কত দাঁড়াবে ইন জেনারেল করতে গেলে? ইন জেনারেল যদি আমি লিখতে যাই এটাকে, তাহলে এটা আমার দাঁড়াবে n3 n2 1। তা টোটাল লেন্থটা কত হবে? n3 তো টোটালটা n3 হবে তো, দুটো যোগ করো দেখো তাই বুঝা গেল? ইজ ইট ক্লিয়ার?
হ্যাঁ স্যার ওটা n2 হবে তো, তাহলে আমি n1 দেখছিলাম সেটা।
না না 2 আছে, 2 আছে। ওইটা ওই 1 টা 2 এর মতো মনে হচ্ছে তো। 1 হচ্ছে, আমি 1 মানে আমার সোজা 1 আর 2 মানে বেঁকা, বুঝলে? হ্যাঁ বলো,
ঠিক আছে
হ্যাঁ বলো।
length of the longer sequence টা যদি odd হয় তাহলে কিভাবে ডিভাইড করব?
You have to add 1 0 and make it even, or যদি বা তুমি যদি লেন্থটা অড হয়, you can add 1 0 to the hn and then you convert, right? You make it odd. But the the situation I am telling you, two sequence has to be same length. Nowhere it is said. Sequence could have different, so sequence could have different length also. Sequence could have different length. So
মানে স্যার ওই hn আর একটা স্মলার সিকোয়েন্স ডিফারেন্ট হতে পারে,
হতে পারে রাইট, n3 হতে পারে, কিন্তু জেনারেলি আমরা সমান করে নিই, তাহলে আমাদের কম্পিউটেশনটা সুবিধা হবে। কিন্তু দে কুড বি ডিফারেন্ট, নট এন ইস্যু, এগ্রিড? বাট this is in case of linear convolution. Two sequence could have different length. In linear convolution, two sequence could have different length also, na? See, this sequence is a direct convolution, this is the length, and this length is different. This length is 2, this length is 8. So in linear convolution, two sequence could have different length. But in case of circular convolution, two sequence has to be same length. If they are not in same length, then we have to use zero padding to make the sequence length equal. Agreed? So you require, for linear convolution, two sequence could have different length, but in case of circular convolution, two sequence length has to be same, right? Circular convolution, but in linear convolution, not an issue. If you have any doubt, you can ask. Otherwise, any doubt if you have?
একটা এক্সাম্পল দেখিয়ে দেবেন না
কিসে?
লেন্থটা
স্যার
হ্যাঁ বলো, tell me.
লেন্থটা অড
লেন্থটা হ্যালো, হ্যাঁ বলো।
আচ্ছা ডাইরেক্ট ক্যালকুলেশন এটা 3 পয়েন্ট থাকলে এরকম ভাবে আরেকটা অ্যাড করতে হবে।
কি বলো আবার? 3 পয়েন্ট যদি থাকে, কিসে 3 পয়েন্ট থাকবে?
এই ডাইরেক্ট ক্যালকুলেশনে যদি ধরুন এই চেইনটা 3 পয়েন্ট হয় তাহলে আরেকটা করে এলিমেন্ট নিয়ে
এই চেইনটা যদি 3 পয়েন্ট থাকতো,
সার্কেলটা যখন করব
এই চেনটা 3 পয়েন্ট থাকলো,
হ্যাঁ,
এই চেনটা যদি
হ্যাঁ
3
এই
পয়েন্ট,
প্রবলেমটা
হ্যাঁ এই চেনটা যদি 3 পয়েন্ট থাকে, তাই তো? এই চেনটা যদি 3 পয়েন্ট থাকে আর ওইটা যদি 2 পয়েন্ট থাকে, কোনো অসুবিধা নাই। ওভারল্যাপ সেম মেথডে, ওভারল্যাপ অ্যাড মেথডে কোনো সমস্যা নেই। ওইটা ধরো 2টো পয়েন্ট থাকলে এটা 3টে পয়েন্ট থাকলে অসুবিধা কোথায়? কোনো অসুবিধা নেই। সেম মেথড ইউ হ্যাভ টু কম্পিউট। সাপোজ এই চেন হ্যাভিং 3 পয়েন্ট, তাহলে এর লেন্থটা কত হবে? n2 টা হয়ে গেল তোমার 3 হয়ে গেল, এন্ড ওটার লেন্থ হয়ে গেল n3 হচ্ছে 2, কোনো প্রবলেম নেই। What is the problem? Same solution. There is no difference in the solution. If the length is different, then not an issue for overlap add method. Since overlap add method, we use linear convolution length could be different, not an issue. So if it is 2 and 3, we work with 2 and 3. In overlap sub method, there is a problem that I will discuss in the next class, where we use circular convolution. Circular convolutions tool sequence has to be same length. Then what we have to do, that we will discuss in the overlap same method. I hope it's all right.